All right, so usually in the first class, I will talk about what's the whole book, right? Because we have book 1, book 2. And in the course, we're gonna finish book 1 and 2 in summer, okay? So that's a lot of work. And in this course, there will be a little bit different ways of doing processing the homework. So each time I will be, after handing out the homework, at the same time, I will also giving out the answer key with the steps as well. So that way we can save time of going over the homework and make sure you understand each question in the homework as well. So in the class, we won't spend too much time checking the homework, going every single step. So we will only go over the question that after you check the answer key and still doesn't understand what the answer key is talking about, right? And then we'll go over that, okay? But still, you need to take pictures of your homework. So even if you just follow through the answer key step by step, write it down, it still helps, right? So you hand in the homework as usual, just that we only have time to go over question that really need help to explain, okay? And now for the overview of the calculus. Calculus, you think of it like a big tree, right? Yeah, I'm gonna draw a tree here. And tree has branches, okay? And this tree has only 2 branches. So the book 1 and book 2, right? And the leaves, they are like questions, right? So this part, you can write it as calculus. Okay, so one side of the branch is called the derivative. Okay, you see it's a thicker branch, right? Because everything else, I think about 70% is about derivative. And then the other side is called integration. Okay, so integration, you need to learn derivative and then think about integration later because they are connected together. So in the middle, we have something called a fundamental theorem of calculus. It connects both sides of the branch. Okay, so if you don't understand derivative, there's no way you can do integration. And what is derivative? Anybody know the meaning of this word, derivative? Jesse, you've learned this part of it already, right? Did you talk about what derivative means?
I think she tried to explain it, but something about like differentiating or something like that.
Okay, what about just the word itself? Do you know, like by dictionary, what it means, derivative?
Like you derive from it.
Okay, very good. Yeah, so we can use that to think about it, right?
Yeah.
Derivative is, if you look it up, sometimes they say it's a tool, right? This one you can just think about it's a deriving something. When you derive something, you must have something to start with. So this is, right? They will in the math context, right? They will tell you, okay, we have a function. We're gonna derive a new function from it. So derive a new one. Okay, so this new function is called a derivative, right? Because we found it from an old one, okay? And then we're gonna use that derivative, the thing that you found, the new function, to use it as a tool to find a lot of stuff. And that application, it has a lot of application, and then you get a bunch of questions coming out from it, okay? So one central idea from the derivative is called the slope of tangent. Okay, I won't go into too much detail, just give you a rough idea, okay? And then integration is got to do with the question, that the application, okay? Integration, what will be the meaning of this word? John, what do you think? Integration.
Like taking what we derived and putting it into something? I don't know. I'm just guessing.
Okay, putting into something. Any other meaning? Integrating. Jeffy?
I would have said the same thing as John.
say the same thing. Okay, so this one, putting into something. Yeah, so we are actually using something we derived to help us integrate. Okay, but in calculus, another meaning will be putting everything together. Okay, sort of like what you said, right? Integrate into something. So put it together, something into something. So if we want to put things together, that's got to do with sum, adding up. Okay, so these are the two main words in calculus. One is talking about the slope on the derivative side. The other one is talking about the sum, adding up in the integration side. Okay, so just get this big picture in your mind first, so you have a map, right, in what we are trying to do here. And then another thing I always like to say about calculus is I always say calculus is kind of like the microscope of math, right? So in biology, you have microscope, but in math, we also have microscope. It's called calculus because it dissects the small things inside. Okay, so later on you will see that. Okay, for example, if you want to find adding up, right, then think about if I want to find the area of this weird peanut shape, right? Then what calculus does is you zoom in and then start adding up little lines together. And each line is changing in length. So if we're able to find the area of every single line, right? Because each line is kind of like a little rectangle, right? You have a length and width, and we keep on adding up, then we get the area of a very, like the side is not a straight side, right? The area of the rounded. So that's the idea of calculus, okay? We look at things a little bit differently. We look at a very little change between stuff, right? Between the shapes, okay? Kind of rough here, right? Very, very rough idea, okay? But I find it very helpful to understand what, right? Because usually you see calculus, okay? It's a very vague idea. So now you have more solid, okay? It has two parts. So the book one is all about derivative, and you will find it much thicker than the second book. Second book is integration, okay? So let's begin our journey. So let's go to here, table content. So first part is talking about limits, okay, which you already got the file. And that file is only part one, okay? Today we hope to finish part one. If not, it's okay, right? It's, yeah. And then second part will be, after you get the book, we'll be doing derivative, okay? So, and then after that, we have techniques of differentiation and then transcendental function. Okay, that sounds very fancy, right? Transcendental. And then after we figure out all the techniques, then we start to have application. You see, derivative has a lot of application as part one, and part two it cannot fit in book one, right? So we put it in book two to do applications. Okay, any questions so far? Okay, so this one is the homework sheet, and then let's start. Okay, so before I begin, right, here, I usually like to use something else, right, to further explain the limits. The first topic is talking about limits. The way I usually think is, imagine yourself walking on the ground, and you're holding a kite. Okay, so here's kite flying, okay? So as you walk along, the kite will be flying up and down. What's wrong? Yeah, did I lose connections?
Yeah, you did.
Yeah.
How about now? Yeah, everyone's back?
Mm-hmm.
Okay, I probably hit a keyboard or something. So when did you lose the connection?
2 seconds ago.
Okay, so you hear about the kite?
Yeah. Well, I heard kite and then it cut off.
Okay, now it's okay, all right? So the kite can go up and down and the person keep on walking. So think of the person walking as the x-axis.
Wait, Jason, are you sharing your screen? Because I can't see it.
Oh,
Same, I can't see it either.
okay, then I'm not sharing, sorry. Okay, it got cut off. Yeah, everybody see it now?
Yep.
Okay, so the person walking is like the x values, right? So x keep on moving to the right side, and then the height of the kite, think of it as the y values. So the y's can go up and down, okay? So the idea of the limit here in this section is it's gonna be if the person keeps on walking towards a place, let's say here is at 1, here is at 10, okay? Keeps on walking towards to 10. So the question we'll be talking about asking is, where will the kite go, right? So kite will keep on flying, right? So think of the path of the kite like a function f of x, right? Y equal f of x. So for every value of x, you get a different height, right? So this one, maybe this starts at 7, right? And then goes up to 10, and then eventually goes down. Right, let's say here will be like around 6, so the kite will fly to here. Okay, so the question we're trying to figure out in this section is, they will say if the person will keep on walking closer and closer to 10, towards to 10, can you predict where the kite will go? Then your answer will be what? Carrie.
Is it around 5?
Yeah, around 5 or 6, right? You predict by looking at the pattern, right? It's flying lower and lower, so you say the limit for the kite is 6 or 5-ish, right? So this is what we're looking for, where the kite goes, okay, in this whole chapter. And then you'll always be walking on the ground and then using the function try to predict where the final value. So you're looking for the y values, okay, in this whole chapter. So just get this idea in head first, and then we'll look at the question, okay, it will make more sense. So let's look at the definition here, okay? So given a function of f of x, so that's the path of the kite, right? F of x, the graph. If the value of x, so that means the person, right, is taken sufficiently close to 8, right? So walking towards 8, so walking towards 10. Make sense? So x is the person, such that the f of x is the kite, right? It's getting closer and closer to L. So L will be like the 5 or 6, right? 5 or 6 as possible. Then we will have this symbol, okay? So the way to say this is limit of f of x as x approaching a, right? So it's a is a value equals to L. Okay, we'll say this together, okay? Everyone together. Limit everyone. Okay,
Limit.
everyone.
Limit.
Yeah. One more time. Limit of f of x.
Limit
Limit of f of
F
x.
of x.
Very good. As x approaches a
As
X
x approaches
A
equals to L.
equals to
equals to
L.
L.
Okay, now we'll try with the example up here, okay? Limit of f of x, everyone.
Limit
Limit
of
F
f
of
of
x.
As x approaches 10.
as x approaches 10.
Right, 10 is right here. Equals to 5.
equals to
equals
5
To 5.
5.
equals to 5.
Okay? Can everybody connect with the picture and the definition here? Are we good? If you are good, please raise your hand. Raise hand so I know you understand what's going on, okay, so far. Jeffrey, do you get it? Okay?
Yeah, sorry, I couldn't click it for a second.
Yeah, it's okay. Right, so let's continue. Okay. All right, so remember we're looking for the y value here. Here we'll start by finding using table value first, okay? So here I give you a function which is 2x minus 4, okay? So this is the path for the kite, okay? And then the person is right here, right? The person is x, is walking towards 1. So you just fill in the table value, okay? So if you look at the table, you can walk towards the 10 from both sides, right? You could also walk from the right side, right? Walk towards here, or you can walk from the left side, right? So that's what's going on here. We have the person walking from the left side 0.5, 0.8, 0.9, 0.99, and so on, towards 1, right? We're approaching 1. And then, or you could walk from the other side. Right side of 1, so 1.5, 1.2, and closer to 1, okay? So please take out your calculator, okay? Punch in all the x value into the function, and then I will ask for your y values, okay? So once you filled up all the tables, please raise your hand. Okay, Jeffrey, can you give me the first 3 values, 0.5, 0.8, 0.9?
I got -3 for 0.5, -12/5, -11/5.
Negative 11/5?
Yes.
Okay, can you give me in decimal, please? Negative 2.4, right? Give me in decimal.
-2.2 for 11/5.
Okay, thank you. Easier to see how the values change, okay, with the decimal. Okay, Jeffy, can you give me the next 2? Jeffy?
Do you want them in decimal as well?
Yeah, decimals.
Okay. Can you give me like 10 seconds?
Okay.
Okay. I have -2.02,
Mm-hmm.
-2.002,
Okay.
and then
Thank you.
-2.
All right. And then let's go from the other side. Anakin, do you have the value for 1.5?
That's -1.
And next one, 1.2.
-1.6.
Okay.
-1.8.
Okay. Keep going.
-1.98.
Okay.
-1.998.
Okay. Thank you. Okay. So we are walking towards the x value of 1, right? This is our target, right? Target. And then the kite is flying towards here, right? The kite. So without stepping on 1, can you tell me what this empty value, right? If you did not plug it in, can you see the pattern where it's heading towards? Gina?
It's heading towards 2, -2.
Yeah, it's on both sides getting closer and closer to -2, right? Left side is a little bit smaller than -2. The right side is a little bit bigger than -2. So we can assume the limit is -2, right? So this one should be -2. And if we plug in 1, do you actually get -2, Lex?
Yes.
Yeah, okay, you actually get -2, right? So for this one, the limit matches the value at the target, okay? So let's make a conclusion about what we see here. So we will say the limit, right? We're following just the sentence up here, okay? The limit of our function, right? F of x equal to x minus 4, right? We're following the sentence as x approaches 1, right? We're approaching 1 here. Equals to what? Emily?
-2.
Yeah, equals to -2. Okay, so the limit equals to -2, right? The middle part is just explaining where the person is walking towards to. Okay, and then the symbol, we'll write it as LIN, and then x approaching with an arrow, right? A 1. And our function is 2x minus 4. So we're going to put the function in here. 2x minus 4. Okay? Don't write f of x because we know what the function is. Equals to -2. So this whole symbol represents this long sentence, right? That's a very convenient, right? You don't need to write the whole sentence. Okay? Anyone has questions so far? So this is the easiest question, right? So we can also see it from the graph. Let's draw the picture first, right? 2x minus 4. How do we graph this one? Gina?
I don't know.
You sure do, okay? This is a linear graph. Y equal to x minus 4. What can you tell me about the -4 and the 2?
The y-axis is the -4,
Yeah, what else?
and then the rise over run,
Which
with-
is?
2/1.
Yeah, so that means you will go which way? Gina?
2 to the right, and then
2/1 is rise over run.
so 2 up and then right 1.
Yes, okay. So please draw the line, okay? 2 up, right 1. 2 up, right 1. Right? 2 up, right 1. To get a line, straight line. Okay? And then to show it's walking towards the 1, right? Well, we want to make it go towards the 1. So this is the target, right? You can draw right down target, right? So the x is getting closer and closer to 1. And then the kite's supposed to fly on the line, right? So you can show it like this with an arrow. So getting closer and closer to here. You can go towards the one from the left side or the right side. So this is the left limit, right? Walking from the right is called the right limit. So there are two sides to the limit. And they both matches to -2, right? Getting very close to -2, these two values. So that's why we say the limit is -2. Even though you did not find 1, you can still predict. Okay? Can we find the limit without making the table? Jesse?
Sorry, my audio cut out. Could you repeat that question, please?
Okay. Can we find the limit to be -2 without making the table?
Yes.
How do we do that?
You just we graph 2x minus 4,
Yeah, and then
and then you look from right side and left side, and then you see if it's -2.
okay. What if we don't have the graph? All we have is a function, and we're not graphing. Can we still?
Oh, you can plug in 1.
Yeah, so we just plug in 1, right? So you without looking at the table at the pattern, right? In this question, we could just find -2, right? We can find this by finding f of 1, right? You just do substitute, right? And then you get the.
Yeah.
Okay. All right, so any questions so far? This is our first question, right? We'll look at number 2. Each of the 3 questions here represent different possibility, okay, of the different types of question you'll see. Okay, so let's look at number 2. We have trigonometry here, right? Sine x over x, that's the path of the kite, right? The function. Can we also plug it in to find the limit here? John?
Wait, sorry, you keep cutting out for me. I don't know if it's my connection or something. Can you repeat your question?
Okay, is everybody hearing me okay?
Yeah.
For
Okay.
the
Yeah, it
most
just
part.
I don't know if it's my internet. It just like cuts in and out sometimes. It happens with my other classes too, though.
Okay.
So I think I need to reset my modem thingy.
Yeah, sometimes you might need to restart, right? Unplug. That's what I
Yeah.
do every time I start a class. I unplug the Wi-Fi.
Okay.
Okay. Do you guys want to do it right now? You can unplug it. I can wait for you.
Okay.
Yeah. Okay. It will be Okay. I'll see you. Okay. I'll wait for 10 seconds. Okay. Oh, Christy is not here. I just saw that. Okay. Let me call her. Right. Joan, can you hear me?
Yeah, I think it's working.
Okay, all right. So let's continue, right? So my question was, can we also find the limit by subbing in 0 here? Jeffy?
Did you say Jeffy or Jesse?
Well, okay, now you answer. You answer it. Can we sub
Oh.
in 0?
Okay, sorry.
Yeah.
You can plug in your like the x into the function.
Okay, so if we want to find the limit for x approaching 0, can I plug in 0 here to find it?
This one, I don't think so, because if you have 0 in denominator, isn't it non-existent
Yeah, okay, so this one,
or undefined or something?
right, you get sine of 0, right? If I try to do that, I get sine of 0, oops, over 0. What is sine of 0, Jeffrey?
Sine of 0 is 0.
Okay, so we will get 0 over 0. What is 0 over 0?
Undefined.
We don't know what it is, right? So this is a weird value. Well, the least we know is denominator can never be 0. So this question is different from number 1 in the way that we couldn't find the answer for limit by subbing it in, right? So we have to find this as just like before, making a table, see what it's getting closer to, okay? So same thing, I would like you to take out your calculator, start plugging in values, okay? Approaching from the left side and then approaching from the right side, okay? And make sure you use the radian mode, right? Because this one is trigonometry. You have to use radian mode here. Okay, so once you got all the values in the table, please raise your hand. And you keep your answers in decimals, okay? So for example, this one is a 0. Okay, I can fill in this one first. The other side is also 0. Remember to raise your hand if you got all the values. Okay, Kelly, can you tell me your value for the left side, starting from over 2?
I have 0. Should I keep it to 2 decimal places or 3?
2 or 3, either one, it's fine.
Okay. I have 0.64, 0.84, 0.99, and 0.998.
Okay, all right, and then now the right-hand side, Anakin, starting from over 2.
I guess I got it in fractions.
Can you put them in decimals?
Okay, hold on.
Okay.
I got 0.63,
Mm-hmm. And
and
then?
then sine 1.
Huh?
Sine 1, which is 0.84.
Okay, and then?
I got 0.99.
Then?
0.998.
Okay, all right. So now, if we try to find the limits, right? Because I cannot plug in 0, you get something undefined, right? But looking at the values beside it, really close to it, can you guess the limit is, Gina?
1.
Yeah, it's getting closer and closer to 1, right? So even though we get undefined at our target, right? This is our target, but you could still have limit. You will still have answer for the limits, okay? So that's what I like you to learn from these two examples. Sometimes you can find a limit by plug it in. Sometimes even though you cannot plug it in, but you still have limit, okay? You still say the limit exists, right? So let's write it here. The limit, okay? I'll let you finish the sentence first by yourself, okay? Follow the same way as we write it, okay? All right, so Emily, can you tell me how to write a sentence?
It would be the limit of f of x is equal to sine x over x
Mm-hmm.
as x approaches 0 equals to
Okay.
1, I think.
Yeah, very good. Approaches 0 equals to 1. Okay, so the value for the 1 is always the y value. You're looking for the y as x approaching to the other x, right? So you have the person walking down there, and then the kite is flying up there, right? Okay, and then please also write down the symbol as well. If you finished writing the symbol, please raise your hand. Does anyone here using like a touch screen as well? Something that you can write on the screen? Anyone? Okay, any question how to write a symbol here? Jeffrey, Leon?
You have lim with
Yeah,
x approaching 0 underneath it,
very good.
and then bracket sine x over x close bracket
Yeah,
equals to 1.
yeah, very good. Okay, so that's correct. Okay,
Sorry, I forgot to raise my hand.
okay, that's all right. All right, so let's continue. The third one, okay, is different as well, okay? Let's box that, right? So this number 3, have you heard of floor function, Jesse?
Absolutely not.
Okay, have you seen this or greatest integer function? Have you heard of that?
No.
Okay, all right, that's all right. Or step function? No?
No.
Okay. So I think it's because I score, it probably going faster. That's why some detail they left it out. Okay. So here we have time so we can go through everything. So this symbol here is not absolute value, right? You see there's a little hook, right, down here, right? So it's at the bottom. That's why it's called a floor function at the bottom. So there's a ceiling function at the top, okay? It will go this way, okay, the opposite. But in the textbook, which you will be seeing in the in your homework, the other symbol that you will see is, okay, you can write it above, okay, with a line like this. Draw a hook here and then line and X. Okay, so either way, they are the same, okay, same meaning. So it's also called the greatest integer function. So what it does is it will output, right? Output means it will give you an answer that would, that is the largest integer that is less or equal to x. X means the number you put in, input. Okay, try to read this sentence a couple times, okay? What this function does, it will give you an answer that it is the largest integer, smaller or equal to whatever you plug it in. Okay, largest, you can think of it as the closest, right? So for example, if I plug in 0.5, what do you think will come out, Jeffy?
Just a guess, but 0.5.
It will output an integer.
Oh, right.
And that integer has to be smaller or equal to whatever you plug in.
I'm guessing 0 then.
0, yeah, very good, okay. So what it means is, I can write it here, f of 0.5, right? Because I want to put in 0.5, which is, I bring it down to the floor, right? The little line at the bottom means you bring it down to the floor, and then you output the 0. Because 0 is an integer that is smaller than 0.5, and it's the biggest one, right? Because the next one will be like -1, -2. Those are all integer. They are all smaller, but we want the biggest one. Does that make sense? Okay, what about 0.8, Emily?
I think it'll also be 0.
Yeah, it will also be 0. I think we
Jason,
forgot.
I have a question.
Yeah. Yes.
When we graph this though,
Yeah.
like everything up until 1 is still 0, right?
Okay, so we'll come on 0, 0, 0. Yes.
And then we get 1, right?
Okay, let's go from the other side first. Okay, 1.5. 1.5, put it in. What would it come out?
1.
1. And then?
And then 1 again?
1, 1, 1, 1, right?
Yeah.
Yeah, and then?
If it's less than or equal to, can we still have 1 for 1?
Yeah. Yeah, less or equal to, right? So if you input an integer, it will come out the integer that you put in.
Okay.
So the middle one will be 1, right?
Yeah.
Yeah. But here we are finding the limit. What do you think the limit is?
Does not exist.
How come?
Because anything less than 1 is still 0, which means you're gonna have like it's gonna jump, like it's the points will
Mhm.
not connect.
Will not connect. Okay, so it will break apart, right?
Yeah.
Yeah. Okay, so let's look at the graph because we forgot to graph the number 2. Okay, remember number 1, we can see the limit coming from the left side, right side, approaching the same place. Then in that case, it will make more sense, right? The kite cannot suddenly transport, right, to a different place. So either way, right, from left or right, they should reach to the same limit. For the second graph, here, okay, we have negative pi and pi, right, getting closer and closer to 0, right here, 0. Negative pi over 2 is 6.4. Okay, so let's say here's 1. 6.4, negative pi is 0, so it'll be here. 0.64 will be a bit higher. 0.84, 0.99, right? So the graph from the other side, same thing, right? Goes up, goes up. So it'll be going up towards 1, but at 1 is undefined, right? So it should be empty circle. It's different from question 1. So the arrow for the limit will go like this, right? Getting closer and closer to it. So that's graph for the second one. So even though it's undefined at 0, the limit is still exists, right? Still equal to 1. So if we try to graph the second one, let's see what it looks like. We have right side, we'll make a couple of them, okay? 1, 2, 3. 1, 2, 3. 1, 2, 3. For 0.5 to 0.99, all these are 0, right? So all these will stay at 0 until it goes to, sorry, wrong place. 0.5 is here. 0.5 all the way to here. If x becomes 1, it jumps up to 1, right? 1.001 will be 1. When x equal to 2, it will jump up to 2 again. Okay, so the graph looks something like this. Okay, kind of like a step. Any question how I get a graph here? Right, you follow the table, right? 0.5, x is 0.5, it stays on 0. Stays on 0 until it reaches 1. It will jump up, right? Stays on 1 until it goes to 2. Then it will jump to 2. So if we try to do the limit approaching 1, x approaching 1. So from the left side, it will go closer and closer to 0. From the right side, it will be closer and closer to 1. Stays at 1 actually, right? So left and right side does not match. When that happens, we just say the limit does not exist. Or we can say the limit is undefined. Okay? So let's write that down here. Okay? So the limit of f of x equal to the floor function as x approaches 0 does not exist. Doesn't exist. Okay, because the left limit and right limit, they don't match each other, right? You don't know which limit to take, right? For one place, you can only have one limit. Okay, so the symbol for this one, x approaching 0 of our function is DNE. What does DNE stand for, Joan?
Does not exist.
Yeah, very good. Okay, or you can write 0 with a line, right? Undefined or empty, right? There's no value for it. However, right, if I ask you what is f of 1, what would you say, Gina? Gina, are you there?
Wait, I'm kind of confused.
Which part?
To I
Where?
don't know.
For this question, which part you start to got lost?
I kind of get it, but what do you mean when you say like for f of 1?
F of 1 means that input x equal to 1. What's the y value?
1?
Yeah, it will be equal to 1, right? So even though the limit does not exist, you could still have a point at the spot. Okay, that's the point I'm trying to get, right? Like over here, for question 2, what is f of 0? Gina, what's f of 0?
Undefined.
Yeah, so this one, the point is undefined. But however, the limit exists, right? We get an answer of 1. This
Oh,
is the
okay.
opposite, right? I have f of 1 equal to 1. However, the limit is what?
1.
The limit.
For which question?
Number 3.
Oh, it doesn't exist.
Yeah, it doesn't exist. So it's the opposite. You could have so having a point at the target, it does not guarantee you get a limit. Okay, that's the point I'm trying to get across.
Okay.
Right.
Yeah.
Yeah. And then, however, for number 1, right, you could have f of 1 equal to -2. At the same time, the limit is also -2. Right. So sometimes it matches. Sometimes you get a point undefined. Sometimes you get a point defined, but the limit doesn't exist. Okay, you see the 3 different examples is talking about 3 different things.
Yeah. Okay. Thank you.
Yeah, you're welcome. Any other questions about this page? This page is very important, okay? It tells you the difference between limits and the regular thing we've been doing before learning calculus, right? Which is plugging points. So compare these 3, okay? Sometimes you get undefined on the point, but you get an answer because in this whole chapter is to find limit. Are we good? If you are okay, then we will have a break first, okay? But I'm gonna invite, okay, yeah. So we'll have a break for 15 minutes and I'll see you at 11 o'clock, okay? And then we'll continue with the next page.
Jason,
Yes?
can
Jesse?
I ask you a school homework question?
Yeah, of course.
Okay, thank you.
Okay.
Wait,
So,
let me just grab the document.
yeah, Jesse? So,
I said, can I just I'll just grab the document for a second.
okay, then you send it to me.
Okay.